There are hundreds and thousands of books on differential geometry that are available. You can search websites, go to online resources, go to shops. You will find so many books. The question is that which is the best book for you? Which book to start with? How will I study? What will be the sequence of study? Do I need to have some fundamental concepts? If so, what are those and where to find the books of those fundamental concepts? In this video, I'm going to answer all the questions and give you a complete understanding on the best book, best resource to study differential geometry. Also, I'm going to tell you where to study, which book to start with, and how to get those books. This is a very important video on the subject, so I would request viewers not to skip any part because this video will change your entire perspective of learning. This video is going to be very detailed, giving you each and every book, the table of contents and everything that you need so that you do not have to hunt forward for books and you find the right book to start with. My name is Shaunak and you're watching this video on my channel Physics for Students. Welcome to the 13th lesson of this continuing videos on introducing differential geometry. So first we will see in what are the topics that we are covering. So we will look into the plan of study. We will look into what are the books for building the basic foundation, examine the details of those books. We will also see what is the detailed table of contents. I'm going to show you each and every table of content. Books on building the foundations of non-Euclidean geometry. What are the essential prerequisites on the mathematical background that you need. Tools for building the concept. What are the concept building books? Differential geometry books. Is it topology or differential geometry? What is the sequence of study? And most importantly, how will you get those books? So these are the topics which we are covering, and we must remember that in the earlier video where I have received a lot of comments and viewers have requested me to make further videos on book, that was lesson number 12, and I really want to thank from the core of my heart for putting up these comments and encouraging me to do more videos on that. So the earlier video which we looked upon, we actually looked on what is the sequence of study. We looked into identifying intrinsic and extrinsic geometry, the visualization. We found out a solution, how to study curves and surfaces in 3 dimensions, how to learn first and second fundamental form, minimal surfaces, and geodesics and Gauss-Bonnet theorem. So you can see that the earlier video was basically a kind of a study guide on what to study, what is the sequence, and what are the areas that which you should study first and then move on to the next. However, in this today's video, which we are talking right now, we would be looking into which book to start with. So the entire focus of today's video, moving from the plan of learning differential geometry, would be the plan of settling with the books. We will also see what is the sequence of studying those books, how we shall study, what is this process and method for study. Now, what I want to say is that in this video of today, we will be talking a lot about books. Now, you might see a lot of books coming on the way in today's video, but remember that you really do not need all those books to study. Now, if you're learning something, you need to have a lot of ideas and then you can learn and focus on something. You really don't need to have, because if you have all those books, what will happen? This is a concept which is called a choice overload. And in this today's era, in the digital world, you get this book, that book, which one to study, you get confused. So just look onto those books and settle down, think which background you are, how strong is your mathematics, do you have the prerequisites, and then let me know what book you want. Right? So it is not a question of sending books or having tons of gigabytes and megabytes of books. It is a question that how we can focus and study and get the study going. So there should not be any choice overload. Okay, so we are talking of books today in continuation of the first lesson, and I would like to tell those who have not watched my first lesson on differential geometry, please go back to lesson number 12 and look into the concepts of studying how you will study curves and then move ahead with the chapters and lessons. Because you're not watching lesson number 12, lesson number 13 won't be useful. So first we will look into what we call the basic foundation of books. How will you build the basic foundation? Then we will look into concept building books, how the concepts are being built up, and then we will see finally the textbook, that is what are the differential geometry books. One by one, step by step, we will look into it. Again, there should not be choice overload. It is not having so much amount of books in your in your library, but reading those books in a proper way. Okay, so first we would talk about books which will build the basic foundation. That means you're not learning differential geometry now, you're building the basic foundation. Now for that I would strongly suggest, although I've made a video on history of differential geometry, but still I would say you should learn a basic idea about the sequence and chronology, how differential geometry has evolved through ages. So why will you learn the history? First is that because you will enjoy learning differential geometry, and there is an old saying that to know the present you need to know the past, right? You really need to know the reason why those theorems came from, otherwise it's a very dry subject, and once you know the reason, the learnings become more effective. So we will look into how these things were being built up. Again, there will be multiple books, but again, you really do not need to learn or have all those books. Just decide which book. I'm just giving you a very, I would say, a clear and unbiased opinion about those books. Okay, so first book which is coming on our way is a very famous, it's a little bit old book, because you can see this is MC Escher's drawing on the cover, which is called Euclidean and Development, Non-Euclidean and History of Geometries. This is a general kind of a customer review on Amazon. I really don't believe on those, because there are many books which you will see which are not there in Amazon, but they're fantastic books. And this was written by Mervyn J. Greenberg, is known basically for his works on differential geometry, and he has done his doctorate under the famous French geometer Serge Lang, and Serge Lang has very wonderful books. I have one on linear algebra. It's quite an advanced one. Just to tell you that this is the person who wrote it. Okay, so these are the contents. So he starts with Euclid's geometry, you see that, and he defined what are the axiomatic method, undefined terms, Euclid first four postulates, and then he goes into logic. That means how do you negate them, how do you use the logical quantifiers, implications, etc. And then he goes directly into Hilbert's axioms, and then he finds something which is called a neutral geometry. We'll find more about neutral geometry. I mean, to see the basic Euclidean geometry, you see the exterior angle theorem, the measurements of angle, and angle sum of triangle, all those things. I mean, to say this is something very naive, something very basic, but that is what is called the neutral geometry. Further, if we see, we will see that independence of the parallel postulate, where he explains the Poincaré model, and there are certain exercises also on the Beltrami Klein model. There are certain philosophical implications on the structure of physical space, and then he moves into geometric transformations, motions, similarities, reflections. I mean to say how Euclidean geometry actually is being transformed, and this transformation is basically done through those things, right? And then we find the discovery of the non-Euclidean geometry, where the contributions of Gauss, Lobachevsky, and other things will come into play. And there are a lot of review exercises, mind it, there are major exercises, there are projects. So it is one big fat book which will not only give you an understanding of the development of non-Euclidean and Euclidean history, but he will make you work on certain things, and I think that is a wonderful idea. Okay, so the final thing which comes are the geometric transformations, as you can see, and he further moves into the results of what is called hyperbolic geometry, and this has got a lot of emphasis on hyperbolic geometry. Okay, so here is my opinion about the book. Yes, it is most comprehensive exposition of non-Euclidean. Remember, the diagrams inside are a little bit sketchy because it is a kind of a traditional orthodox book. It is very dense, obviously. It has got a lot of historical facts, proofs are quite well made, and the very basic overall understanding of geometry is very clear. So it is a classic book. It's a book which you can refer many times if you're teaching differential geometry in classes and you're a professor or a lecturer. This book will serve the purpose. So we are done with the first book, where we are basically building the foundation, knowing the chronology of development of Euclidean history. The next book is this one. It is a little bit odd name, Worlds Out of Nothing, right? It is a Springer book, and the Amazon rating is more about 60%, some about something like that. And this is the person who wrote Jeremy Gray. He was born in 25th of April, and he is basically interested in the history of mathematics. So I will just quickly glance through what are the topics that he has covered in this book, and I will give you a basic review of what this book is about. So here it starts, right? You see he lists out basically from the French Revolution, and that is very important because Monge, Gaspers, etc., these are people who really contributed right from the beginning about differential geometry. So then comes the Poncelet, pole and polar. Then he goes into theorems of projective geometry. Then he goes into Poincaré's famous triad, right? And then he further moves into the duality and duality controversy, Poincaré and Chisels. That is the, if you have really gone through it, I mean to say, this is super. This is just an amazing book. You can just go through it. This is the famous, duality controversy. And then he goes into Chasles and Steiner's cross ratio. And then he finally moves into what is called a projective plane. So it gives a kind of a very, I would say, very comprehensive and a historical. So you will see through your eyes how things are being discovered or things are happening. He covers also Lambert and Legendre. Then comes Gauss, Boly, Lobachevsky, and then non-Euclidean geometry is being finally accepted. So you see that is how it happens. And then concepts of fundamental geometry. These are, I know that on the screen it might be a little bit small size, the font, but I cannot help it because otherwise it will take too long. So the disk model comes after the fundamental geometry, that is the rise of projective geometry, and he used the Poincaré model, the Poincaré and the Beltrami disk. I mean to say the disk, I would say the pseudosphere concepts comes in, the geometry of space, and then you see at 27 he puts up a summary in the geometry till 1900. Then the formal side comes in, the physical side, and then further approaches in whether the geometry and so on. So this is a kind of a historical journey he takes out, Jeremy Gray, Professor Gray, into that. So yes, we can say that it is a good book, but it is a little bit different. Now, what do I mean by different is that the way the book has been written compared to the book that we just we just saw, the building of this Mervyn J. Greenberg's book. It is a little bit unconventional writing. You might find that something is skipping one after the other, but it is really not. It's a very comprehensive book. But you sometimes it seems to be odd. That is the style of writing, right? Proofs are very well made, and you come to know really a lot of things about the French Revolution, how things go. So you get a complete picture of what you're studying today and how it started by using through that. I will quickly go over the third book, which is written by this wonderful lady, and this is named Geometry Through History. It's written by Megan I. Dillon, and Dillon is basically from the University of Virginia and BA with major in mathematics. This book is very coincised. I mean to say, she doesn't expand too much on that, and he just starts with the elements of Euclid. She moves to neutral geometry, hyperbolic plane, Hilbert's famous Grundlagen, there's the foundations of geometry, and then she moves into affine geometry, algebraic curves, and so on. Simple. I mean to say, very clear. Okay. Now that we have known that the foundations of differential geometry starts with knowing the history, the next question comes is that what would be the sequence of study? I mean to say, which book we should read first and which book we would read next. The first, my suggestion would be this one, Euclidean and Development of Non-Euclidean. Then you can read Worlds Out of Nothing, and Geometry Through History would be Dillon's book would be the third one. So these three books would be in sequence, and let us not skip. You do not go to Jeremy Gray's book right at the beginning. You get lost. right? So that would be a sequence of study. So that is basically building the basic foundation, and now we are going to study what is the foundation of non-Euclidean geometry, because once we know the history, then we move into the geometry, and the geometry is basically non-Euclidean geometry. I first like to show a very unusual book. Now, I'm sorry for the cover because I cannot find a better resolution cover. It is Foundations of Euclidean and Non-Euclidean Geometry. It is written by Ellery B. Gauss. Do not go into Amazon and try to find this out. I think you can find, but not much of the details of this book. Now, he is basically known for his maths texts, Patterns in Mathematics, a wonderful book, and this one. So he is basically hired at Ohio University and worked as a math professor. Now, before going into the details of this book, I would like to show you how this book is arranged. Now, this is a tremendous arrangement, great scientific way, so that the entire concept is clear. So, part 1 of this book deals particularly with the insights and motivation to approach elementary geometry. I mean to say, students often fail and they feel demotivated that why should I learn geometry? This part explains and gives you a lot of motivation to learn for that. The second part is to introduce the student to modern rigorous approach to the foundations of geometry using notations, etc. And the third part is basically what we call is devoted to non-Euclidean geometry. Now, this is, I mean to say, this is all in all what we say that this is the way the book has been divided, and you see that is very I would say very logical, because you need to know, have the motivation to learn, obviously, then you go and learn the approach to the foundations of geometry, and then finally you moved into non-Euclidean geometry. So a quick glimpse on the table of contents. So here are the ingredient and tools, finite geometries, properties of axiomatic system, criteria, critique of Euclid, and axiomatic development of elementary geometry, and then comes the non-Euclidean geometry. Now, what is important, I mean to say, the table of contents shows a very comprehensive answer. What is important is that how he approaches the book in a very scientific, and I think this is something really astounding. Now, you see I have underlined, so here he says, see, let us define a pencil as a sharp tool used for writing. This satisfies the criterion of simplicity, which means that any definition should use ideas and words so and so. So to anyone who does not know what a pencil is, the following definition would be obviously incomprehensible. We can say a cylindrical instrument tapering to a conical point as implied by an amanuensis. So the definition, what he is saying, is basically not complete. So it is simply not possible to define every word without getting trapped into an infinite loop so and so, and the dictionary definitions are basically circular. So you see what he does right at the beginning is that he is trying to define the definition in a very scientific manner. Because each of these definition, for example, he has used pencil, something goes in circle. That means the definition is not correct. Let me show you further few lines that he says that if you want to use a dictionary of a foreign language knowing nothing and had available in a dictionary, it carries no meaning. So to avoid the problem, it is necessary to choose some words as primitive or undefined terms. And he says the definition of pencil as a sharp tool used for writing satisfies the criterion, but it fails to comply the non-circularity, because sharp tools used for writing can have circular meaning. So what he says here is that to sum up any good definition, it must be expressed simply and in a non-circular and most uniquely characterizes that is being defined. So you see the wonderful beauty. Before starting anything, he uses a simple analogy of a pencil, and he used that circular definition should be avoided. And most importantly, you will see below that with this in mind, let us look into the first three definitions in Euclid's Elements. Now, with this definition, with this limitation, when we go into Elements of Euclid's, we really understand why it has been defined and why we read definitions so much. I mean to say, definitions we are reading not only in differential geometry, we are also reading in real analysis and so on. So this gives a really wonderful approach to that. So these are not good definitions, and he goes on explaining that. Now here he gives another example. If one says he was the greatest mathematician who have ever lived, one is not really making a statement, right? So if the sentence is changed to Beethoven was the greatest mathematician who has ever lived, or Gauss was the greatest mathematician, anyway, Beethoven was not a mathematician, he was a musician, anyway, was the great mathematician, then the sentence becomes a statement, a collection of words to which the labels are true and false. That means after defining what is the definition, he wants to prove whether that statement is true and false, and here comes the logic gates and everything which he has used here. Right? So this P and Q and what is true and false. So I just wanted to show you how wonderfully this has been organized. And if you are teaching differential geometry, I think this would be an ideal way to define differential geometry and start the concept building of Euclidean and geometry and so on. Okay. So quick look on what are the contents. So we have looked onto that. So one of the best books to build the foundation, easy to understand, clear and simple. Entire chronology has been defined. Logics, proofs and geometry constructions are well explained. Okay. Now we come to the next book by Ma Press. You know what is the meaning of MAA. Okay, so the review says more or less around 61%. This is a book by the Mathematical Association of America. This is by this person, Matthew Harvey, known to be very popular on his books and explaining clearly the difficult concepts of differential geometry to his students. Okay, now this book, before going into the detail of this book, remember that this requires certain prerequisites. That means the development of distance function, which the Professor Harvey has used, uses Dedekind cut. The development of pseudo-sphere model for hyperbolic geometry, definitely you need to have a good concept of multivariable calculus, equations of inversions of hyperbolic geometry, complex numbers. Somehow the complex numbers are not being covered in this book, and calculation of geodesics on pseudosphere, multivariable calculus and differential equations. So Geometry Illuminated almost comprises a kind of a self-complete book where the professor teaches you what you really don't know except complex numbers, which are equations of inversions in hyperbolic geometry. That's a point you must note. So the part 1 of this book is again organized same as earlier, neutral geometry, congruence, distance, etc. Part 2 is the Euclidean geometry, which deals usually with the school level axiom, circles, circumference. Part 3 starts with again Euclidean transformations, and part 4 deals with hyperbolic geometry. This book, I mean to say particularly, not with the previous one, this has a little bit more stress on what we called hyperbolic geometry, and I think that is a good way to do. So here is the table of contents for neutral geometry. I'm not taking much time. You can take a pause and take a screenshot. Starts with axiom, models, congruence, this, that, etc. Then we move to the Euclidean geometry. This is the table of contents: circles, circumference, centroid, simple. Then we come to the Euclidean transformations, which confirms analytic geometry, isometries, reflections, how the translations from Euclidean geometry really takes place, the inversion, area, barycentric coordinates, and applications of inversion. The hyperbolic geometry contains this. It starts with the pseudosphere, which we just noticed, geodesics on pseudosphere. It contains lot about Poincare disk, hyperbolic trigonometry, and also tiling, which is taken as an exercise. Okay, so the sequence of study would be more or less this. You can start with geometry illuminated, and then you can move into foundations of non-Euclidean, or either way. I mean to say both of them are equally good. There is no point in comparing or giving a kind of a number 1 or 2. You can start with anything. Okay, so we have done with the foundations of non-Euclidean geometry, and now we start with the concept building books. Now, concept building books means what? Concept building books basically means that each subject that we have discussed in the earlier video, we will see a quick recap. What are the books? I mean to say, what are the things that we will study? And we have known that we are studying with curves and surfaces. So the first book, I mean to say, which will start with curves and surfaces, is by Marco Ebat and Francisco Tobena, and this is a really wonderful book. And okay, so this was the authors who actually did it. I think Marco Ebet is an Italian and Francesco Tovena is a Spanish or a French, I really don't remember. Anyway, so you see that there is one thing very important which I have been telling in my earlier lectures of differential geometry is assumption, are the prerequisites. So here you see what is written, that we do not require you to have exposed to algebraic topology in particular, right? So there is no need for topology. For this reason, section 2.1 contains a complete introduction to the theory of degree for continuous maps, so and so. So it starts and it tells you that you don't need to know algebraic geometry, topology. So this was the last video, right? Plane curves, locus properties, and this is what we are looking into this also. So you start with local theory of curve, we just saw it. Then it goes to global theory of plane curves with S1 Jordan curve theorem. And you see these what we have just we are talking about, these lists we have completed in part differential geometry in my lecture in part 12. So the sequence is now completed, and now it is a question how we can master each and every lesson and what are the best books for that, right? Okay, so local theory of surfaces, it comes with curvatures and things like that. Okay, so we further see that the book actually comprises of curvatures, geodesics, Gauss-Bonnet theorem, and global theory of surfaces. So whatever we just saw, we discussed, it is being covered. So it is absolutely an excellent book. The next book, which teaches us more about curves, spaces, or curved surfaces, we can call curved spaces actually, and this has got a fair good rating, 85%, and is written by this person, Professor Pelham Wilson. And these are basically the the content. So it starts with Euclidean spherical triangulations and Euler numbers, then it moves into hyperbolic geometry. So what you will see, you might say that these are more or less the repetitions, and yes, you are very right, because the overall approach and the study guide of those books are the same. And what I am trying to show is that repeated nature of the same, I won't say the same topic, but the same way these books have been organized proves that we are going in the right path, that these is the sequence of study, and that you need to study lesson number 12, video number 12 first, and then come to 13, so that you really understand. You see, geodesics we have talked about, Gauss-Bonnet theorem also we have talked about. So this is actually an excellent introduction to the field of differential geometry, and wonderfully self-contained. That means you really do not need to consult any other book. If you really don't know a concept, Professor Wilson is going to teach you. This is a book which I have, to be very honest, I mean to say I have not got into much depth, but because it is an AMS book, so you can just go through it. Non-Euclidean geometry and curvature, and it contains these chapters and many more. But anyway, this is just a kind of a quick note to you. Okay, now we learned about the Gauss-Bonnet theorem, which I talked about the different parts, but I am not going to show you any other book about Gauss-Bonnet, because all those books which I have just shown and further I would be showing, all of them contains the Gauss-Bonnet theorem. So nothing to with that. So now we come to the central part, that we have built the history. We have known the foundations of Euclidean, non-Euclidean geometry. We have also known the curved surfaces, I mean to say curvature and surfaces, etc., 3 dimensions. Now we are ready to go into differential geometry books. But before going into differential geometry books, I want to take a note of this. The first is that some of the books assume that you know topology, right? And some assumes you do not know topology. Choice is yours. But when you, with the books assume you know topology, you should go for self-complete books. Because if you're not a complete master, or you really do not know topology in that sense, then you should go for self-complete books. Then the concepts of neighborhood and topological space and embedding, etc., the author will complete in that book. And assuming that you do not know topology gives a much easier way of approach, and that is what exactly we are going to do. I'm going to show you books which assumes you do not know topology, because again, if I have to create a precursor of what topology subjects you need to know in order to know differential geometry, that would be a separate video, but I cannot cover it here. Actually, it's out of scope. So first would be this wonderful book, Differential Geometry, Curved Surfaces. Thomas Bankoff is indeed a great author. So this is more or less not goods. You see 37. But do not go by the reviews of customers of Amazon. This is Stephen Lovett and Thomas Bankoff, wonderful writers. So here you see again, before starting, I have given in red, we shall not prove these assertions as a proper discussion of simple connectedness would make too far into the realm of topology. That means this book again assumes that you do not know topology, right? And if you're talking of simple connectedness, I have just made a video on topology a few months back. You can look into it. We shall not prove this assertion as a proper discussion of simple connectedness. The readers should feel free either to skip the technical details of the proofs. But that means you can just skip it. There won't be any problem in learning. That is how they tell. And here it shows similarly in the field aperture that is outside the scope of this book, right? So this is the beauty. It doesn't require to the knowledge of topology. The second book would be my favorite. I would say Andrew Priestley's Elementary Differential Geometry. I think I have talked about this book in my last year's video. Customer is rating is around 24%. And for standalone course in differential geometry, this is one of the most clearest and most accessible texts. That means not much of difficult complex mathematics is given. Here also I would like to take a note for readers unfamiliar with point set topology. This means roughly so and so. That means this is a self-complete book, right? Because it says that this is explaining what this point set topology, that means a self-complete book, right? So I've just given a note that proving global results about this concept of topology, since we are not assuming readers. So it is again showing that it is not assuming readers to know topology. And this is the basic, I would say, covering the contents. Curves in the plane space starts with how much it does a curve, and here you see it covers the first fundamental form, Gaussian, mean and principal curvatures. Further we see that it covers geodesics, Gauss theorem, egregium, hyperbolic geometry and Gauss-Bonnet theorem. The next book which is in my mind, which I would definitely suggest, of Christian Barr, a German mathematician. This is the customer review, and this is the gentleman who wrote this book. This is I won't say this is almost close to a classic, yes. And when I say I mean that, I will just show you what are the wonderful topics that this professor is covering. So it starts with Euclidean geometry, right? Then it goes into curve theory. Then it again goes back into classical surface theory. That is first fundamental, etc. Then it goes into inner geometry of surfaces, isometries, etc. And we turn the pages and we see here. So it goes into geometry analysis and geometry and topology. I mean to say this is just a beautiful book, and it is one of the textbooks you should be going through. That's elementary. So book is clearly little, and yes, it has got beautiful colored graphics right in the middle of the book. Okay, so where do we stand now? We see there is another very, very famous, a relatively easy book of Barrett O'Neill coming up, that is Elementary Differential Geometry. Customer reviews is 68%. This is the person, and he is basically known as writing books and contributing significantly to differential geometry, and the 18 research articles published in 1973. Let us see how beautiful this book is. So here again you see the introduction says that knowledge of elementary calculus and linear algebra. That means it is saying that you really know the concept of linear algebra, because here it says the reader will, for example, frequently called upon to use chain rule, etc. But its proof, it is not a concern. So this is a kind of a note. Prerequisites, yes, you need to have a good hold of elementary calculus and linear algebra. So this starts with calculus on Euclidean space, frame fields, Euclidean geometry, calculus on surface, shape operators. So this book is clearly a classic, I would consider. It is a perfect introduction to the field of differential geometry. It is very concise, I mean to say not terse and well organized. It's a good subject and content, and this is an excellent introduction to differential geometry, and it has got numerous exercises with answers which makes it appropriate for self-study. Now we are going through the books, but are we done? I mean to say, this is the last phase of the video where we are discussing about differential geometry. Are we done? Now this is the last and the big monstrous book of Michael Spivak's. Everybody knows the famous, world's famous book, A Comprehensive Introduction to Differential Geometry. You will see this is 4 volumes. To be very honest, I have never gone through all those volumes, but just picked up what I really need. But there are certain prerequisites. Right, there are certain prerequisites. Here are those. So the book assumes that you know multivariable calculus. You really have a strong background of I mean to say linear algebra, abstract algebra, and also here it assumes point set topology. So you see, I've been talking that some books assumes that you know topology, some books do not assume, but Michael Spivak, Professor Spivak, assumes that you know point set topology. So if you do have those 4 points, go through that. Now we come to the sequence. I mean to say, we saw a lot of books. What is the sequence of studies of differential geometry? So first, my preference would be Barrett O'Neill's book. It is pretty easy to understand. The second, go to Christian Barr's Elementary Differential Geometry. Third, or you can even swap between 2 and 3, Andrew Plissler's Elementary Differential Geometry. Also fourth would be Differential Geometry of Curves and Surfaces. You can put this 4 at the beginning if you feel that you're lacking certain fundamental concepts, and if you permit or your time permits, then you can go through this famous book of Michael Spivak's Elementary Introduction to Elementary Differential Geometry. Now this is the sequence. The question is that how do you get all those books? I mean to say, you can ask me for all those books. You can make a sequence and which you want, because it should not be, as I told you, should not be overburdened with books. So very simple. What you need to do is that you can either email me at contact.physicsforstudents@gmail.com. You can WhatsApp or have a voice call with me regarding the books, or if you're confused, you can even ask me that which book should I study for. And what I'm going to do is that, because these books are quite heavy, I'm not going to send it as an attachment. I will share it in Google Drive. So when you download those books, give me a buzz over WhatsApp or an email that it is downloaded, so that I can delete that and make it free for other people who wants this book. So this is a very comprehensive, detailed kind of approach on what are the books. And I know it has been long and video, and I really thank you for being with me, for watching this video. So thanks a lot for watching this, and please subscribe to my channel, help me grow. Click on the bell icon and click on all to get all the notification from Physics for Students. If you want to contact me, you can write to me at this email ID. And if you want to look into my new channel, which is slowly growing, that is where I explain mostly only about general relativity. So here is the channel. Further, you can follow me over Instagram, Facebook, and LinkedIn. So that's it. Thank you very much for watching. I think the books I have given you a lot of clarity in terms of studying, the direction, where to go. Let me know if you need those books, and please do comment on the video, and I will be back again with yet another video, and we will continue this learning of differential geometry through various ways, avenues, and sometimes also through refreshing our concepts on certain fundamental areas of differential geometry, which serves as the pivotal force of learning. Thank you very much for watching this video. Have a good day, and may God be with you. Goodbye.